So next up, we're going to learn about the quick sort. So quick sort is a divide and conquer algorithm which picks an element as a pivot and partition the given array around the picked pivot. So what is pivot element? You can choose, like we're going to talk about this in quick sort in detail. So first I'm going to go one by one and I'll make you understand each thing. So from here you can see a pivot you can pick in different ways. Always pivot the first element as the pivot element, always pick the pivot as the last element. So you can choose whatever element in that array to be pivot element. So we will choose that last element to be the pivot element, or you can choose random also. Anything, any value is you can choose as a pivot element. Now what does this pivot element means? So let's jump to the whiteboard and understand what this pivot element means actually. So we jump to the whiteboard and we will one by one see what does this pivot element means. Alright, so here you can see the quick sort. Alright, so we're going to see each and everything about the quick sort. So here we can see that quick sort is a divide and conquer algorithm, right? So what does that mean? Like we're going to divide larger array into smaller array, you can see, and it will recursively sort the sub array. That is what we're going to do actually also, right? Now in this, when you're going to solve this quick sort, we're going to see three things to see, like so three things. In that three things is going to be the pivot element selection, partition function, and finally applying the process recursively. So first thing we're going to see, that is the pivot element. We will choose last element as the pivot element and we're going to create partition function. In that we're going to apply this divide and conquer thing. So how to get that pivot element in the correct position? It means whatever the element we choose, that has to come to the right position, right? So we'll get that thing at that position. Okay, now if I talk further, that then how are we going to do it? Let's say this is one array is there and we have to do it in quick sort. So let's understand by this example, then you will get it better, right? So what we're going to do is we're going to go one by one what actually we are doing over here. All right, so here you can see that 10, 25, 3, 50 and 20 is there, is the array, and index is 0, 1, 2, 3, 4. All right, we chose what I said, that we will choose the last element as the pivot element, and we chose that. You can see pivot is 20. All right, now after choosing the pivot equals to 20, the next task is used to partition the array. So what is our, like partitioning array means we have to write one partition function. In that function what will happen is we actually get the pivot element to the correct position. So if we see from above, 20 is the last element, his correct position is in the second position. If it would have been a sorted array, then 20 would have been there in the second position, right? So we will rearrange all the elements in such a way that all values lesser than the pivot element should come to the left side and greater than should come to the right side. That is what we're going to do. So what we're going to do is at the end of the partition function, pivot element will be in the sorted position. So that is actually going to happen. So we'll take two variables, that is p index and I, iterating variable, and we'll initialize the p index and I to be 0 initially. Then we'll check that if array of I is less than pivot or not. So if it is true, then we have to swap the element at I and p index at the last time. That time we'll do. So let's understand what this actually is saying, array of I is less than pivot or not. Okay, so this is our original array, 10, 25, 3, 50 and 20. What we said, we'll initialize I and p index to the 0. We initialize it and we choose pivot element as a last element. You can see we have chosen also, right? So this is the element, is the p index, and this is the I also, right? And this is p index also. Okay, now, and this is what? This is the pivot element. Now what you're going to do is we have to that check array of I with the pivot. We have to check array of I with the pivot. So array of I is what? 10 is less than 20. So if it is true, so we're going to swap it I with the p index. We will swap it with I and p index, as p index has same value, so no change in the swap. So array of I and array of p index is what? Both are same. Array of I, because p index and array like I is pointing to the 0th position right now, isn't it? Now if I say, so here after swapping 10 will be swapped with 10, so that's going to be in the correct same position, right? Now after that, what is going to do, what's going to happen is I is going to be incremented. It was true that 10, whenever it's going to be true, array of I less than pivot, that time will increment p index, remember this. So we increment p index, and I is the iterating variable, so automatically it's also going to be incremented, so both are pointing at the same position. Now 25 is going to compare with the pivot element, that is 20. 25 is less than 20 or not? No, it is not. So condition is false. So p index will remain in this position, but I is a iterating variable, so it will go on. So I will be pointing to 3 now, and p index will be remaining at the same position. You can see I is pointing to third one, but here you can see that this is pointing to the p index is pointing to the 25, right? Still, okay, not this is the not part. Okay, here I is pointing to 3 and p index to the 25. Now again, array of I is going to be checked with pivot element. Array of I is what? That is 3 is less than 20 or not? Yes, it is less than. Then it's going to be incremented. So p index is going to come to the third position. So now you will say that how 3 came here. So here, whenever it's because that is the end of the iterating variable. That after that it's not going to work. So that time we will swap it. We said one rule also, that at the last we will swap it, right? So again, once going to be checked, the condition is false, then at the last here will be what? Here 3 is there and 20 is there, right? So it's going to be swapped between both. The condition is there after swapping 25 3, because that condition is true here, so we swapped it and it's got the array like this. And after that, the condition is false, this one condition is false and incremented, and I is going to the end. At the very last, what we're going to do is we're going to swap pivot and the p index. So pivot and p index of 20 going to come here and 25 going to come there, right? So after, if you see that start is pointing here, 10 is going to be the start, then this is going to be the end, this is going to be the end, all right, and this is going to be the p index. Okay, so this is the partition function, and we have to apply that partition function. So let's see how this partition function will work. So we'll go to the VS Code and we'll see each thing one by one, and we'll implement all things whatever we said. So in the quick sort function, we're going to call the partition function, that we're going to get the array and we're going to divide it and we're going to conquer it, right? And after that, we're going to write right sub array. For the left sub array, that's going to sort, and for the right sub array, it's going to sort, right? So we're going to do that, and it will sort each and everything. All right, so let's jump to the VS Code, and for this one we'll end it here and we'll go to the VS Code and we'll solve the implementation of quick sort. We jump to the VS Code. Now we'll implement the quick sort algorithm. So how it is done? So whatever the theory we learned, that is how it is defined. So that's the way we actually do it. So I'll write quick sort dot java, let's say. I'll hit enter. Now class will be created. Okay, I'll come out of it here, and here I'll write one. I have to write what? Swap function. I have to write partition function. I have to write quick sort function, and I'll write display function also, and main method also I have to write. So these all are things I have to write. So I'll be writing one by one. So what I'll do is I'll write public. I'll write the first of all I'll write the swap function. So it's going to be very easy. So public static void swap function, and in that swap function I have to swap between those elements. If you remember, array were there, so we were swapping between p index and I, right? So we will take array over here, int whatever array it comes, it's going to do its task. Let's say we'll take variable I and another variable int j, right? Three things is required, isn't it? So j I'm taking over here. Now here what I'm going to do is, here we're going to write the function. So I'll write int temporary variable, and that's from going to come from array of I, and we will write array of I is equals to array of j. J value is given to array of I. Alright, now array of j is going to come back from temp variable. That temp was storing the value of array of I. So this is the swapping function, right? This is done. Alright, now I have to write the partition function. So in partition function, you remember that we're going to choose the last element as a pivot element, and we initialize the partition index, that is p index, and I, like I will always start from start, so we're going to start from 0. So we have to do that. So for that I'll write the function public static void. No, I'll do what, I have to return the index. So I have to take the integer, right, that type, and I'll write partition, partition function I'm writing, and here I'm going to take input as array. We're going to take the input, array is going to go there, starting position of that array and end position of that array. Okay, now what you have to do is, here we have to choose the pivot element. So what is the pivot element? You already know. I'll declare one pivot variable, that is going to be array of end. End element is our pivot element. So this is how we choose pivot element. Now if I want to choose the p index, we already know that p index will be given as starting position. So start I'll write, and this start will give value at the main function as 0, right? So here, from here we are getting the start. Okay, now I'll write a for loop that I said that in that I'll iterate and I'll check between I and pivot element. You remember we were checking between, if that is there, then we're going to swap it and increment the p index. So that is what we're going to do, and at the very last, if this is over, then we're going to swap between p index and pivot element at the last, right? So what I have to write is end I equals to start, I less than end, and I plus plus. And here, if array of I is less than pivot, if it is true, whenever it is true, that time we swap it and increment the p index, right? Swap between what? Swap between I and array of I and array of p index, right? So what you're going to do is, here we're going to call the swap function, and we'll pass array in it, and we have to do between I and p index. Okay, swapping done. Now I have to increment p index also. So I'll increment p index whenever it is true. After this for loop is over, we're going to swap between last, that p index that came, and we're going to swap between pivot element, right? So for that, what I have to do is, I'll write a swap, I'll call the swap function. So swap, and here I'm going to write what? Array, and it's going to be here end is the pivot element, right? End, and we're going to do it p index. So this will basically place the pivot in the correct position. This swap basically put the pivot element in the correct position. Okay, I'll close this, so it should look good. Okay, this much is done. Now at the end, I will return the p index, that is going to go to the p index, that is going to go to the quicksort function when you go to write. All right, this is all about it. Now I'll declare quicksort function. Basically I'll write public static, so we'll be writing as void, and I'll write quick sort function, and in that I'll pass what integer of array int start int end. And here what I'm going to do is, here I'm going to write one condition: if start is always less than end, if start is less than end, that time we will enter this. Like we know that start is always going to be less than end, right? So int, I'll be storing it in p index, and in this what I'm going to do is I'm going to call the partition function. So here we'll get the thing over here. So here will be start and end. So this is the partitioning of the array. This function will partition the array. Okay, and we got it. Now after getting it, we have to sort the left sub array. So it is going to do recursively, and right sub array. So left sub array, you already know that I'm going to write quick sort for left sub array. To do it, starting will be same, but it's going to go till p index minus 1, right? So that is going to be the left sub array, because p index is already in the sorted position, we don't have to sort it. So p index minus 1 is the left sorted, like it's going to sort the left side. Now if I write quick sort function and I write p index plus 1 to end, if I go, then that will sort the right sub array, and that is done recursively. You can see from here p index plus 1, and that's going to recursively solve it. So this is all about it. Now if I try to write one display function also, that I also can write. So let's say how to write the display function. Let's see it. I'll write public static void display. All right, and in this display function I'll take the array as the input arr, and what I want to do is I'm going to write that give the statement system dot out dot println, and in this I'm going to say that sorted array is, and that is going to be the sorted array, right? So I'll come over here and I'll go to the next line. So if I write the for each loop, you already know that how to write for each loop, because we used lots of times. Now we're going to write the for each loop. So int for, I'm going to take one variable for every num in array, print the num. For every num in the array, num variable, print the num. So I'll write system dot out dot println num, and this is there. All right, after doing this, what I'm going to do is I'll come out of here and write system dot out dot println. I'll give some enter over here. All right, this is done. Now I have to write one more thing, that is the main method, right? So I'll write what public static void and main method, and in this main method what I'm going to write is I'm going to pass the string array args, and after this, inside this we're going to get the array. So array we're going to declare, let's say arr, and here I'm going to give some values, let's say 78 67 90 23 56 74. Let's take more values, 71. So these are the elements. If I want to sort it, what I have to do is, let's store the size in some variable. So in size, and I want to write array dot length. So this is going to get into the size. Now I'll call quick sort function. I'll call quick sort function, and here I'm going to pass array, and what I'm going to pass is size, that is going to be the size minus 1. So above we can see in quick sort what you have taken. We have taken starting index and the end index, the quick sort, right? So what you're going to take is starting index we're going to take is what is 0, and end index that is going to be what, size minus 1. So that is going to be the end index. Okay, now this much is done, and I'll at the last I'll just call the display function also. So here we'll pass the array, and this is done. I'll hit Control S to save it, and I'll click over the run button, and it will build it and run the code. Let's wait for the running of the code. Okay, the sorted array is 2356. Okay, if I want to get into the same line, what I have to write is I have to remove this ln from here, and I'll hit Control S, and I'll run it again. So after running it again, you can see 23, 56, 67, 78, 71, 74, 78, 90 is the sorted array by quick sort algorithm. So this is how we do it. So we're going to see few good examples like quick select algorithm and lots of types of questions that we're going to solve it. Before that, let's cover all the topics one by one. Then we're going to jump to the questions. Thank you.